Hi, I'm Dr. Jerry Jones, and I'm inviting you to join me while we discuss precordial transitions. I teach classes in Advanced Electrocardiography and Advanced Dysrhythmia analysis, and I find that my students are often a little bit confused about precordial transitions. So let's get started here. Here we have an ECG with a normal precordial transition. And in this case, the precordial transition occurs right here at lead V4. Now, we can determine precordial transitions by first an equiphasic QRS, which is preceded by a predominantly negative RS complex and followed by a predominantly positive QRS complex. You're going to see an example of this in a moment. Or the first lead with a positive QRS complex. Now, normally, a normal precordial transition occurs from lead V3 to lead V4. Here is another ECG with a normal precordial transition, and this time the precordial transition occurs at lead V3. Now, what's interesting here is that lead V3 is an example of an equiphasic complex. Now, this indicates the exact point of the precordial transition. However, these exact points, the equiphasic complexes, are usually located in between leads. So we don't normally see an equiphasic complex, but we have to look for the first lead with a predominantly positive QRS complex, a large R, small s. Okay, now we're going to discuss some of the problems in determining where the precordial transition lead is located. I want you to take a few moments to look at this ECG. You can pause the video at this point and then start it up again when you're ready to continue. Did you decide where the precordial transition occurred in this lead? It occurred right here, not here. I want you to be careful because the precordial transition is not just a change in the polarity of the QRS complex. It's specifically the change from a predominantly negative QRS complex to a predominantly positive QRS complex. This change occurred before lead V1. Now, here is an example of an early precordial transition that takes place in lead V2. V1 looks okay, but the transition occurs before lead V2 because lead V2 is already predominantly positive. So lead V2 is the first lead to manifest the transition, the first lead to manifest a predominantly positive QRS complex. Here is an example of a late precordial transition. In this case, the precordial transition occurs right here after lead V6. Now, here is a normal precordial transition, and the transition occurs right here in lead V3. Now, the reason I'm showing this ECG is because sometimes people will look at V4, which has a much larger QRS complex, and say, oh, the transition occurs here. Well, that's not true. The transition occurs in V3 because that's the lead with the first predominantly positive QRS complex. It doesn't make any difference what the amplitude of the R wave is. Now, we can determine whether or not there is a normal precordial transition in the presence of a right bundle branch block. In this case, the transition occurred in lead V3. But with right bundle branch block, we have to use the initial R wave in V1, for instance, and not the large R prime. The small R wave actually represents left ventricular depolarization. So we follow that small R wave through the precordial leads. And through that, we can determine the location of the precordial transition even in the presence of a right bundle branch block. Right bundle branch block, however, can sometimes present a little confusion. In this case, the precordial transition is late. It occurs after V6. And the reason for this is the fact that we have a left anterior fascicular block. Now, a left anterior fascicular block often accompanies a right bundle branch block, but it produces a marked left axis deviation, which almost always moves the precordial transition after lead V6. But it's still a valid determination because even in right bundle branch block, whether or not there is a left anterior fascicular block, we can still determine the precordial transition. Now, here we have an ECG with a left bundle branch block. This presents a major problem. The progression of the left ventricular depolarization is concealed within the QRS complex in left bundle branch block. Therefore, the precordial transition cannot be determined in left bundle branch block. If you have a left bundle branch block, don't worry about the precordial transition. You cannot determine it. Now, I'm inviting you to come join me in Houston or in London and be a participant in one of my master classes, never just an audience. I teach both advanced electrocardiography and advanced dysrhythmias. So come join us and be a participant. Thank you.